Hello, everyone. We are back with the next one, introduction to functions. So, a couple definitions. A relation is defined as a set of ordered pairs. We learned that relations can also be described with a table of values, an arrow diagram, a graph, and an equation. So, this is from all the way back in our first lesson. The domain of a relation is the set of all the first elements of the ordered pairs, and the range. Oh, the range. Sorry. And the range is the set of all the second elements of the ordered pairs. So the first elements, we also call them the inputs. The second elements, we also call them the outputs. The inputs, we also call the independent variables, so independent. And the outputs, we also call the dependent variables. So the dependent variables depend on the value of the independent variable. Some relations have a certain quality that make it a function. So we're going to introduce this idea of a function. Very specific mathematical definition of a function. Examples of relations that are functions and relations that are not functions are shown below. Examine these relations to determine what makes a relation a function. First, with a set of ordered pairs, relations that are functions on the left. I'm paying attention to the elements of the domain. So the domain occur in the first values of any ordered pair. I have 3, 5, -4, and 7. So elements of the domain, so that's in an ordered pair, it's the first number. Elements of the domain do not repeat. And that is clear from this example. What about on the right side? I have 3, 5, -4, and 3. 3, 5, -4, and 3. The 3 and the 3 repeat. 3 repeats, and 3 is an element of the domain. These are the first numbers. Therefore, not a function. Next one. 2, 3, and 4. 2, 3, and 4. Once again, elements of the domain do not repeat. 5, 5, 5. 5, 5, 5. Once again, 5, 5, 5. So 5, 5, 5. Not a function because the 5 repeats. In an arrow diagram, how do I know it's a function? Only one arrow from each element of the domain. This is an arrow diagram. So basically, I don't want elements of the domain to repeat, so I look for one arrow, only one arrow, one arrow, one arrow, one arrow, one arrow. If I do the order pairs for this, that is 1, 8. So you'll see that the first values of the order pairs don't repeat. 1, 8. Oops, sorry. 1, 10. 2, 8. 3, 12. And 4, 10. I don't care about the outputs repeating or the range. I care about when I'm determining a function that, hey, none of these inputs or the elements of the domain, none of these elements of the domain repeat. And you can see it right here, 1, 2, 3, 4. Okay, so it is a function. How about this one? I have, right away, I have 2 elements. So 2 2 arrows from my input of 1, right? So if I did the ordered pair here, that would be 1, 8, and here's my repeat, 1, 10. Right away, that's not a function. So 2 arrows from my input 1, so this is not a function. So 1, 10, 2, 8. The rest look okay, 3, 12, and 4, 10. But here is where, right here, the 1 and the 1, right here. So 2 arrows coming out. That is not a function. Next one. Let's look at a table diagram. 5, 3.6, negative 7, 4. So this would be your domain. And then the second part of the table will be a range. So likewise, let's domain and range. So this domain, what am I looking for? Elements of the domain do not repeat. All right, so that is a function. How about this one? Repeat, repeat, irrational, irrational. So elements of domain repeat. So this is not a function. How about in graphical format? This is a discrete relation, number 5. I'm just looking at elements of domain. So I'm looking at x values, not the y values, right? So look on this axis and look at all the x values. So elements of domain. So x values, elements of domain do not repeat. Is that true? Well, that's -3, -2, -1. This is 0, this is 1, this is 2, and this is 3. Remember, only x values. If I mark these out as, let's look at each of these points, and let's make ordered pairs, and you'll clearly see that x values do not repeat. So let's go here. That's -3, 2. That's -2, 0. That's -1, -1. That's 0, -4. That's 1, 2. That's 2, -1. And 3, 1. Take a look at all my x values. 3, 2, 1, 0, -1, -2, -3. Elements of domain do not repeat on the x value. So this is from a graphical standpoint with discrete variables, or sorry, discrete relation. Let's contrast that with the next one here. -3, -2, -1, 0, 2, and then I have a 3. Look at this part right here. I'm repeating, so I have a 3 and then another 3 for x values. Remember, we're only concerned with x values. Let's write out all our ordered pairs, and you can see -3, 2, -2, 0, -1, -1, 0, -4, 2, -1, 3, 1, and 3, 2. Do the elements of my domain repeat? Yes, they do, right here, 3 and 3. Remember, we're only concerned with x values, x values. So not a function because repeat x value. So elements of the domain repeat. Number 6. On this, looks like a semicircle, do any of my x values repeat? So if I pick any random x value along this entire curve, if I pick here versus here, right, I can see that elements of the domain do not repeat. How about here? If I pick a random x value, let's pick 1. Well, I have this value here or this value here. And you can see for this circle, you have the same problem on this side. If I pick an x value of 4, I have 2 possible values on this circle. So this is not a function. Why? Because x values, or values of the domain, repeat. In the next couple pages, we will show you a method of how you can tell a function quickly, how you can tell a graph of a function or graph of a relation is a function or not by a thing called the vertical line test. We'll do that in the next couple pages. Okay, let's go to the next page. Examine the above relations that are functions and the relations that are not functions and determine what makes a relation a function. So the question I would ask is, do the elements of the domain, this is the key question, do they repeat? A function is a relation where each element in the domain is associated with exactly one element in the range. Okay, that is the technical definition of a function, but the question, really the important part of this lesson is, how do I determine something is a function or not? I look at a relation, how do I know it's a function or not? Well, I have to ask that question to myself, do the elements of the domain repeat? Or, technically speaking, does each element of the domain, does it have exactly one element associated within the range? This is a bit harder to comprehend when you're looking at something and determining if it's a function or not. I like asking this question. Do the elements of the domain repeat? If the answer is no, then it is a function, then function. If the answer is yes, then not a function. Okay, what is even a function? Let's talk about this. A function is like a machine for each particular input. So this is the independent variable, independent, or also domain. We put into our function, so for each particular input we put into our function, it will only generate one output. So output would be your dependent variable associated with your dependent variable, or your range. So one element of the domain is related to exactly one element in the range. So we put in our input, it's like a machine. Here's the analogy with a machine. This box is a function and it puts out an output. For example, if our function is expressed as an equation, y equals 5x plus 3 is the equation of a line, then the function machine would work as follows. The domain, or the input value of 7, if we put 7 into this machine, we only get exactly one output. So if this is the function, so what is going on inside this function? Y equals 5 times, this is x equals 7. Remember, y equals 5x plus 3. This is your input. So I'm inputting 7. And then this is my output. Somehow I get a 38 output. How do I get that? 5 times 7 plus 3. This is what's going on inside the function machine. 35 plus 8. And then I get an output of, 35 plus 3. And I'm getting an output of 38. For this function, x is the input, y is the output. The input is always the independent variable, and the output is always the dependent variable. So dependent output, dependent, and this is usually your y variable, and then input independent and usually your x variable. Okay, let's go to the last page and we'll solidify what we just are learning here. How can we tell if a relation is a function? If a relation is represented as a set of ordered pairs, then it is a function if the first elements of the ordered pairs are all different. So in this case, this is from our opening example, -2, 0, 3, 7. So no repeats. Remember I said look at it from the perspective of no repeats. So no repeat. Here's the problem I have. Repeats. Okay, so function, not a function. How about a table of values? If a relation is represented as a table of values, then it is a function if the elements in the first column are all different. All different. But I like to think of it as no repeats in the domain. All you have to look at is the domain. So this is the domain. No repeats. How about this one? I have red and red. Same. Or, in other words, I have repeats. So therefore, not a function. Left side, function. Number 3, if a relation is represented as an arrow diagram, then it is a function if there's only one arrow for each element in the domain. So the left side of an arrow diagram is the domain. One arrow, one arrow, one arrow, one arrow. Okay? One arrow for each element of domain. Another way to say this is no repeats. If I ordered pair this, that's 1, 9, 2, 12. Oops, sorry, not 1, 9. This is 1, 12, 2, 12, 3, 9, and 4, 17. Look at all the elements of my domain. 1, 2, 3, 4. No repeats, therefore it's a function. This one, good so far, one arrow. Good so far, one arrow. Oh, problem. 2 arrows. 2 arrows. This is a repeat. So therefore not a function. If I make ordered pairs, 1, 12, 2, 12, 3, 9, here's my problem. 3, 17, and 4, 17. Where's my repeat? 3 and a 3. This is a repeat, so therefore not a function. Okay, last one here, and this is where I talked about the vertical line test. When you have a graph, I can do this quick thing called the vertical line test to determine if it's a function or not. So what happens when I draw vertical lines? If a relation is represented as a graph, then it is a function if there is no point directly above another point of the graph. A graph represents a function when no 2 points lie on the same vertical line. So right here, if I draw this vertical line, let me just draw a series of vertical lines here. Okay, if I draw this vertical line, it goes through only one point. This vertical line, only 1 point. How about this one in between? Just 1 point. You can draw a series of vertical lines. I will never go through more than 1 point. Why is this important? Because if I'm only going through 1 point, here, and here, and here, and here. If I'm only going through one point, I'm not repeating elements of the domain. So no repeats of x values, or another way to say that is elements of the domain. I'm only showing one intersection point here. There can't be more than one. So this is why this is a function. How about the next one? If I turn this graph on the left 90 degrees to the right, let's do the same vertical line test. Okay, when I do this, that's fine. That's just one point. But the moment I go here, that's 2 points. So let me just pick an integer value to illustrate this. Let me go right here, this one, right? Oops. Right here. Let me illustrate with this one. Why is this not a function? So here's the vertical line test. It fails. So first of all, I'll say this vertical line, I have 1, 2, and this vertical line produces a point of 1, -2. Well, I'm repeating elements of the domain, 1 and 1. So 1 and 1. So I have point 1, 2, and 1, -2. And I have what? Repeated elements of the domain. Right? So this is my x value, therefore not a function. And you can see that with many, many other points, like right here and here, right here and here. It's going to fail the vertical line test. Okay, so I should make that distinction here. So multiple points where there's repeated elements. So this one fails the vertical line test. While the function on the left, 1 point, 1 point, wherever you put a vertical line, just 1 point, no repeat. So this one passes the vertical line test. So therefore it is a function. All right, so vertical line test is a visual way, and it's a fast way to determine if a relation is a function or not. If all vertical lines intersect the graph of a relation at most one time, then it is a function. If any vertical line intersects the graph of a relation more than one time, then it is not a function. So this is a VLT, vertical line test. This is a quick, easy way to determine from a graph, is it a function or not? All right, next page, get some practice, and we will see you for the next lesson. See ya.